Here we go, number sequences, predicting the numbers that will come next. Okay, number 1, we've got number sequences when the number gets bigger. In this situation, it's quite clear that the numbers are adding to each time. So we go 13, 15, and 17 for our last 3 numbers. They don't always go up by the same amount each time. Look at this example. We go 2, 4, 8, 16, 32. Clearly not the same amount is being added each time. But if you look closely at the numbers, you will notice that each time you're not adding 2, but you're timesing by 2 or doubling. So we'd get 64, 128, 256. Next we have one where the amount's getting smaller. This one, they're going down very evenly by taking 2 each time. So our next numbers will be 29, 27, and 25. Next one is a little bit of a rat bag. Yes, they're getting smaller, but they're not getting smaller by the same amount each time. So here, individual arrows will help a lot more. Here we take 10, here we take 9, here we take 8, and here we take 7. You can definitely see the pattern there in these numbers that you're taking away, whereas if you didn't write these down, you may well make a mistake. So next we need to take 6, which will give us 60, then take 5, which will give us 55, then take 4, which will give us 51. Stinky rat bag. Oh, now we haven't covered fractions yet, but I wonder if we can do some headway with this one or make some headway with this one. From 3 1/2 to 4 3/4, we have added 1 1/4. 4 3/4 to 6, we add 1 1/4 again. 6 to 7 1/4, we're adding 1 1/4. So we've established here we're adding the same amount each time. Add 1 1/4 again, and we go to 8 1/2. Well, you could put 8 2/4. 1 1/4 again would give us 9 3/4. And here's the tricky one. It's so tempting to put 10, but it's not. If we add 1, we get 10 3/4, then add our extra quarter, we actually get 11. That's the place where most people make a mistake on these type of sums. Official stinky rat bag. Yes, the numbers are getting smaller, and they're getting smaller by a factor of 10 each time. So here we've divided by 10, and here, and here, and here. So divide by 10 again, 0.02, 0.002, and 0.0002. Stinky rat bag alternating ones. Now these are really weird because you quite often find with number sequences they either get bigger or they get smaller, but this is a strange one. As you notice as you go along here, first of all it gets bigger, then it stays the same, then it gets bigger again, then it goes down, then it goes up, then it goes down. Very weird. If that happens, then keep in mind an alternating number sequence and see if this works. Let's have a little go. So start with your first one and join it to your third one, join it to your fifth one, and join it to your seventh one. On the top here, we've got our second, joining onto our fourth, joining onto our sixth, joining onto our eighth. It's a little bit like 2 sets of fingers interlinking. We've got 2 number sequences that interlink with each other. So the number sequence along the top, 2, 4, 6, 8. So if we were to go 2 numbers ahead, we would have 10. And down underneath, I'll change colour just to help make it a little bit clearer. We've got 1, 4, 9, 16. Now those are square numbers. So for our next number to go in here, we would need 5 times 5, which is 25. Because this is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. If you see a number sequence where they go up and down along the sequence, try an alternating number sequence. It does sometimes work. Now this is great. This is called sausaging. Sometimes you get number sequences that aren't just along a line, but they're actually in a grid. So here we use sausaging, which means basically putting sausages around numbers. So here we have got 42s, which we put a sausage around. We've got 38s, which we put a sausage around because they're all 38. We've got 34s, which we put a sausage around, and the poor little 30 all by itself. So if we need to work out this value of x, what we can say is, okay, let's move along the sausages this way. From 30 to 34, we add 4. 34 to 38, we add 4. 38 to 42, we add 4. So to get to our mystery number x, we have to add 4. Every time we move one place, we add 4. So our mystery number is 46. Try this one. Here we go. I might see if I can make this slightly smaller, actually. Nope, not going to work. Okay. Right then, so I'm going to sausage again. Let's go. A sausage around 66. The 84s are the same. The 102s are the same. The 120s are the same. A bit difficult to see how much you're adding each time. So what I'm going to do is I'm just going to look for this easy option here. Now here I know from 102 to 120 is adding 18. And it's the same here. And it's the same here. So if I add 18 again, I'll get 138. And the last one, here we go. Sausaging the other way this time. We've got all our 31s making a sausage. We've got 35s making a sausage, 39 and 27s. So if we move this way, we know we're going to end up getting to Z if we repeat the process. So from 39 to 35 is take 4. 35 to 31, take 4, 31 to 27, take 4. So if we take 4 again, we will get 23 as our value for Z. Quite a few complicated methods there, especially the sausaging and the alternating methods, but if you follow these processes, they generally help you to find the missing number.